looking at target 7.4, I can use the properties of a polynomial function to create a graphical representation of the function. Create a rough sketch of the function with the following key features. Okay, so if it doesn't give you that much information, it's pretty simple. Okay, so we have real zeros at x equals -3, 0, and 4. Again, these real zeros are where it's going to be at the x-axis. Okay. So I have -3, 0, and 4. My end behavior, well, the limit as x approaches -infinity of f of x equals infinity. So remember, x approaching -infinity, this is the left going up. So on the left side, to the left point, I'm going to finish going up. This is the right, and it goes down. So on the right side of my last point, I'm going to end going down. Fabulous. Now I'm just playing connect the dots. So I start at my arrow. Okay. This is a sketch that follows this. Okay. So now let's write our equation of this function. So I have my real zero at x equals -3. That's going to give me x plus 3. At 0, that's just x. And at negative, oh, I put it +4. Let's pretend this is +4. That's going to be x minus 4. Sorry, that was totally my bad. Or you usually put them in order. So my first distribution is x squared plus 3x squared. I can't write today, guys. Then I have x squared times x, and x squared times -4, that's x cubed, and x squared minus 4x is -4x squared. Then 3x times x is plus 3x squared. 3x times -4 is -12x. Combining these, we get f of x equals, we have x cubed, -4 plus 3 is -1x squared, -12x. Now I'm going to use this graph to fill in my properties. I'm not going to worry about y-intercept. I put it in here, but we're not going to. Nah. Okay, maximums and minimums. So I just kind of threw this together, but my minimum value, right, my maximum value is here. We'll say it gets up to 2. My minimum value is here. We'll say that's at -2. Okay, so I'm using this as a review more than being super strict about it, right? But we're going to say it's about here that our minimum point is and about here that our minimum point is, or our maximum point is. Okay. Domain, again, we should be good at, right, domain is our easiest one. Domain always goes from -infinity to infinity. Our range, we're looking for our lowest of our lowest point, right? This goes down forever. So our lowest of our lowest point is -infinity. Then I'm looking for the highest of my highest point, no matter where it is. This goes up forever. So our range is also -infinity to infinity. It is easy enough to look at this and know that it's going to look like that. Again, this is an odd function. Our end behaviors are going in opposite directions, so we know we're just going to go down forever. One side goes down forever, one side goes up forever. Increasing. Remember, with increasing and decreasing, if you do them at the same time, it's easiest, and you're just kind of deciding where things go. So I'm going to start at -infinity. I want to eventually get to positive infinity, and I'm going to stop at my important points along the way. For increasing and decreasing, my important points are max and mins. Okay? So starting at -infinity, the first thing I come to is our minimum here, which is at x equals -2, right? That's my first stopping point. From here to my minimum, it's going down, right? Because it's at its lowest point at the end. So I'm going to sort that into my decreasing part. So -infinity to -2 is decreasing. Then I go to my next important point, which is this maximum, right? Between -2 and 2, I'm going from a minimum to a maximum, so I have to be going up. Then my next, right, I don't have another min or max, so I'm going to infinity. And that is decreasing, right? I'm starting at a max and going down from there. Positive, negative, same idea. I'm starting at my -infinity and my infinity, stopping at important points. This time my important points are x-intercepts, okay? Starting at -infinity, I get to my first x-intercept at -3, right? That part of the graph is above my x-axis. -infinity to 3. Starting at -3, I get to my next important point at 0. Right? This, everything here is below, so that's why it's negative. Keep going, my next important point is at 4. Okay, so between 0 and 4, I'm above the x-axis. Then 4 to infinity, right? I am below the x-axis. Okay, so you're going along, stopping at your important points. All right, let's look at example 2, same idea. Real zeros at x equals -5, 1/3, -1, and 1. What? Let's hope I get my zeros correct this time. So I'm at -5, 1/3, which is just past 0, -1, and 1. Oh, those are close together. That's fun. Okay, so then with my end behavior, right, the limit as x approaches -infinity of f of x equals -infinity. So on the left, it goes down. So I'm going to go just to the left of my last point, and it's going to end up going down. On the right, ooh, it also goes down. So here's my last point. To the right of it, it's going to end up going down. Now I'm just connecting my dots. So I have to go through this point, through okay, beautiful. It's a beautiful function. Again, writing the equation of the function. Ooh, this is a fun one. So I have x plus 5. And remember, these slide. I'm going to have 3x minus 1. X plus 1. X minus 1. All right, let's start multiplying. 3x squared minus x plus 15x minus 5. So we have 3x squared plus 14x minus 5. I'm just going to bring down that first one, so I have x plus 1. I'm going to multiply again. So I have 3x cubed plus 3x squared plus 14x squared plus 14x minus 5x minus 5. Whew. So again, combining like terms, I have 3x cubed plus 17x squared plus, combining these, I have 9x minus 5. Last multiplication. So I'm doing this one times this one. That's 3x to the fourth. This one times this one, minus 3x cubed. This one times that one, plus 17x cubed. This times this, minus 17x squared. This times this, plus 9x squared. This times this, minus 9x. This times this, minus 5x. This times this, plus 5. So I have 3x to the fourth. Negative 3 plus 17 is plus 14x cubed. Negative 17 plus 9 is minus 8x squared. Negative 9 and negative 5 is minus 14x plus 5. Success. Okay. I will never ask you to do 4 zeros, okay, on like a test or a quiz. But it's kind of fun to do in notes, right? There's just a lot of algebra, a lot of multiplication and addition. All right, so if you kind of keep yourself organized and just chug along, it takes a little longer, but there's nothing too difficult. Okay? All right, turn the page. Our last example, example 3. Real zeros that x equals 7 halves. So 7 halves, if I'm graphing this, right, how many times does 2 go into 7? Oh, it goes in 3 times, and there's a half left, right? So I'm going to go to 1, 2, 3 and a half. Oh, I don't like this. Can I change this to, I just don't like when they're that close. Let's change it to negative 1. Okay. And then we'll put this at negative 4 and this at negative 1. I like them spread out a little more. So then on the left, it goes down. So just to the left of my point, I'm going to end up going down. And to the right, it goes up. Connect my dots. I'm going to try and do that. So let's go get up to 2, that's fine. And then let's go way down. Make it a little more fun. Okay, so same thing, writing my equation. This slides out. I have 2x plus 7. Nope, 2x minus 7. All right, change the sign to negative 4 becomes x plus 4. And negative 1 becomes x plus 1. Multiplying. 2x squared plus 8x minus 7x minus 28. And we get 2x squared plus x minus 28. Bringing this part down. 2x squared times x is 2x cubed. 2x squared times 1 is 2x squared. X times x is x squared. X times 1 is x. Negative 28 times x is negative 28x. Negative 28 times 1 is negative 28. So then I have 2x cubed plus these combine. 3x squared plus these combined, negative 27x, that really should be a minus, minus 28. That is our beautiful function that we graphed. looking at part B, again, we're just going to quickly go through our intervals. Make it that big. That's fine. Okay, our, again, x-intercept we're not going to do. Maxes and mins. My maximum is here. It has a maximum value of 2. Minimum is here. It has a minimum value of 1, 2, 3, 4, 5, -6. Okay. Again, domain. Nothing ever stops our domain. It goes all the way through from -infinity all the way to infinity. Range. I wish I had one with a range. This one, again, it goes all the way down. It does have a piece going all the way down, and it does have a piece going all the way up. Increasing and decreasing. I'm going to stop at my max and my min. So I'm going to start at -infinity and go to my first max or min here. So from here, so it looks like -2.5, I'm increasing. Then going to my next max or min, which is here, right about 1.5. So from -2.5 to 1.5, right? I'm decreasing. I'm going from a max to a min. And then going from a min up forever, okay? So that's from 1.5 to infinity. Okay. That's this piece here. Again, positives and negatives. I'm going to start at -infinity again, but now this time I'm stopping at my x-intercepts from -infinity until, oops, I went way past my first x-intercept, sorry. There's my first x-intercept, right? So from -infinity to -4, I'm below. Then from -4 to what looks like -1, right? And that is above. And then from -1 to 3.5, you can call it, or we know it is -1 to 7/2. Either one. It's below. And then from 7/2 to infinity, it's above. Okay. All right, that is it. I'll see you guys tomorrow.